want to go on to what forms the basic aim of all this so far as our lab is concerned. Of course, we have done quantum key distribution, we have established prepare and measure, entanglement waste, all that is done. But what we really want to do is increase the distance over which such communication can happen. And that is what leads to long distance quantum communications. And our project is called Quantum Experiments Using Satellite Technology, or QUEST. And so the idea is that we have a ground station here, and we have a ground station somewhere else. And we use a satellite as a trusted node to establish a quantum link between these two ground stations. And why we would do that, we just come to that. So why satellites for QKD? Because there are distance limits for quantum channels. So now all that I have been saying so far, I've of course been talking about lab-based demonstrations, and you can take it a bit further and so on. But even if you go ground-based, which is, of course, the usual, you are on the ground, and very much we are grounded people. So we are on the ground, and so Alice and Bob are communicating and they are exchanging a key. The typical distance that you can reach with ground-based QKD is around 100 kilometers, okay? And demonstrations can happen, let's say, up to a maximum 300 kilometers. So what happens beyond that is you don't see each other. So essentially, of course, the Earth is round, and so essentially the horizon becomes a problem. So beyond a point, it is not very viable to continue doing this by line of sight. And so that is why there is a natural limit to ground-based free space QKD. Then you can use fibers, for instance, as an example of fiber loops and so on. So, but then fibers also, they have losses, right? So this is the kind of typical loss. So beyond the point, you can't do fiber-based either. Because of course, what you do in usual communication is, of course, through fibers, we have these repeater stations, right? So after some distance, we have a node where, there is some kind of a device which is, amplifying the signal, and then it is going to the next station. So there is a classical repeater involved in these fiber-based, classical, communication. So, but if you do it in quantum, then, we have heard about the no cloning theorem. So you just can't do it in the same sense as the classical. So these are the problems with free space and fiber-based QKD. So if you want to go to longer distances, you need to do something different. And so one of them is trusted repeaters. And in fact, this is a bit outdated. It's not underway. In fact, there is a 2,000 kilometer network now, which is the Beijing-Shanghai link in China. So they have been able to actually link Beijing and Shanghai using some trusted nodes and QKD. So this is one way of doing this. Or you can use entanglement-based repeaters. We will just discuss a little bit of that in the next slide. And then, so these are all at the research level. The Beijing-Shanghai link is not at the research level. It's already existing, but then it has its own issues. It's not quite, there is this thing of trust. So you have to trust these nodes. So the two ways in which the global community is trying to increase the distance is by, understanding the repeater technology better, or by using satellites.